Okay, we're talking about the wind tunnel. We experienced the wind tunnel had an opening of diameter 8 feet, which means, of course, it could be fit inside of a square 8 by 8. It could be inscribed within that square. If anybody has heard the word inscribed, and I don't know what's been taught in our geometry courses, but it's entirely possible that you didn't. But I reckon that you probably did. Okay, and you inscribe a circle here, right? Mm-hmm. Okay. So you have these two circles. Now I say, what's the ratio of the area of this circle to this circle, right? Mm-hmm. I didn't mention the squares, and everybody told me it was twice the area. Okay? I mean, obviously, you know, if you do x over the way, I'm trying to think of the way you would set this up. You would have like 16 over 8, right? So it'd be like x over a equals 16 over 8, right? And you cross multiply and do all these things that you're doing, probably without any reference to the actual rules of arithmetic, to the laws of arithmetic, okay, which is something you need to do. You just kind of automatically set this up because you're conditioned to set up equations like this. And then you get x equals 2a, right? And if x is the area of this one, okay? And now you're convinced. However, if I do this, I get 4 8 by 8 squares, and I know that this has to have 4 times the area. Yeah. And then I conjecture by geometric similarity that this circle has to have 4 times the area of this one. Mm-hmm. Okay? And we could go further in the conjecture. We could divide this up into 10 million. Actually, 10 million is not good because it's not a perfect square of an integer. We could divide this into 100 million little squares and divide this into 100 million little squares. Every one of those little squares here would be 4 times the area of every one of these little squares. And you count the little squares inside of here and you get something very close to the area. Of course, you multiply that by the area of each little square. And same thing here, right? Mm-hmm. Since each little square here is 4 times the area of each little square here, you're basically proving, if you take this to a limit, that this has 4 times the area of this. Okay? Now that's just an overall sketch, but that's how you think about it and reason about it. You don't think of area as formulas, you think of area as area. Okay? Geometrically. Formulas bypass geometric intuition, which you need to do much of anything in most of mathematics. Okay? And we bypass it because the SOL doesn't require you to understand it. And you know, the schools are between the rock and a hard place. Your teachers would like to do more, and some of them manage it, but it's very difficult when you have a class full of people who don't really want to learn it. That's kind of the dynamic, okay? So we established that this has 8 times the cross-sectional area of this, right? Mm-hmm. Now the question I asked was, what's the diameter to length ratio of this compared to that wind tunnel that we saw, which was 100 yards long and 8 feet in diameter, right? Mm-hmm. Well, you could write down the numbers, but the result is pretty clear if you just visualize what that would look like if you scaled this one up to the same diameter, right? This one would be a lot shorter, which means that this one has a bigger diameter to length ratio. Okay? Now, why are we asking this? Well, let's do that in a different video.